Now we're going to start to go over the periodic table. In 1860, Dmitry Mendeleev in Russia came up with a list of elements. He put elements into an order. He assigned them atomic masses that they knew at the time and their properties. He kind of put these on cards, and then he would arrange those cards in columns. He would put elements that had the same properties together in a column, almost like a suit of cards, with the lightest elements at the top and the heavier elements towards the bottom, almost like arranging a suit of cards by putting a deuce at the top and an ace at the bottom. And then he would take these columns and he would put one column next to another so that the mass also increased as you went from left to right. So he published the first periodic table around 1860. This is what his periodic table looks like. Looks a little bit different than the one we have today. You notice there are a lot of blank lines in here. One thing about Mendeleev's table that was important is that he left spaces where he figured elements belonged, but at the time they hadn't been discovered. And because they were in the same columns with elements that he knew, and he knew their properties, he was able to predict the properties of these undiscovered elements. And when they found them, they fit right into his table. So this told people his table is something that's real important. Now, a modern table is broken up into three groups of elements. We have metals, metalloids, and nonmetals as you go from left to right on the table. You notice there are many more metals than nonmetals or metalloids. Now, I put the metalloids in green so they'll kind of stand out a bit. Now, let's check out some of the properties that these things have in common. All metals are shiny and ductile. Now, ductile means you can draw it into a wire. They're all good conductors of heat and electricity, and they're also malleable, which means you can hammer them into shapes. Nonmetals, on the other hand, are the opposite. Nonmetal actually means not a metal. So nonmetals are dull, brittle, and poor conductors of heat and electricity. The opposite of a good conductor is an insulator, so nonmetals are good insulators. Now, metalloids, being right in the middle there, are better conductors than nonmetals, but not as good as metals. So you notice they have some of the properties of both metals and nonmetals. Now, one of the most important metalloids for today is silicon. We find silicon in chips in computers. And without silicon and its properties, it's a very lightweight material, almost a plasticky kind of material, but it conducts electricity. And we would never have computers today. Okay, the modern periodic table is separated a little bit different than Mendeleev's. So let's check these out. First of all, the table is broken up into periods or groups, and these are the horizontal rows. And if you count them, there are 7 of them. The first row contains just 2 elements, hydrogen and helium. The second row goes from lithium all the way across to neon. Now, if you look down here near the bottom of the table, see number 58. Number 58 would fall on number 57 up here. So the middle of these last 2 periods was pulled out and placed at the bottom of the table. And this shortened the table, made it fit much better on a piece of paper. And as I'm going to see later, it actually lends some ideas about atomic structure too. So, periods go across, and groups of families go down. So we have 18 groups or families. And we can number these families 2 different ways, as you see here. We can number them 1 through 18, or we can number them as A and B groups. So you notice 1A and 2A are over here, and then it jumps way over to 3A all the way to 8A. Now this can be very helpful when we're going over some simple atomic structure, as we will later on. We're going to separate now the table into some important families. And the first important family are the alkali metals. The alkali metals are the most chemically active of the metals. And if you want to see some of these metals in action, you can go down here to the periodic video site and view experiments done with these. And that's a great site here. If you go there, you can click on sodium and watch about a 5-minute video of all different reactions with it. So alkali metals, the most chemically reactive metals. In group 2A, we have the alkaline earth metals. You see some common ones, magnesium and calcium, you've heard of those. These are not quite as chemically active as the alkali metals, but they're still more chemically active than the common metals in the middle. Now the next group we have is really a block of elements, and those are the transition metals, where you find the common metals that we see around us. Those two rows at the bottom are also transition metals. So that's our biggest group of elements. They show a gradual changing of metallic properties towards non-metallic as you go from left to right. On the right side of the table, we have the most chemically active nonmetals, the halogens. That's group 7A or 17, with fluorine, chlorine, bromine, and iodine. Those are very chemically active and are all toxic to us. And then we have group 8A or 18, the noble gases. This was the last family of elements to be discovered. And the important thing to know about the noble gases is that they don't chemically react with anything. They are unreactive or inert. So sometimes they're called the inert gases. Now these elements do not form compounds. They're only found all by themselves, mostly stuck in with other elements in the ground. So they have to be mined for the most part. And they're the key for understanding chemical reactivity.